All right, so what we're talking about today is chapter 18, which deals with confidence interval for proportions. Last chapter, we learned about dealing with proportions and means for samples, but now we're going to spend some time focusing on proportions. Okay. All right, so a confidence interval, it helps us apply things that we learn from a sample to almost any sample. Before, remember when we were working, what we said was only based on that certain sample. And confidence intervals now are going to let us apply what we find for any size sample to the population. All right, so the confidence interval, the statement that you say is that we we are 95% confident if it's a 95%. A lot of times it might be something different like 98%, 92%, but the general one is going to be 95 unless otherwise stated. So we are 95% confident that the true proportion of blank, 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 it's going to depend on what you're looking at, what your sample is talking about. That's where you enter the context. So we're 95% confident that the true proportion of blah, blah, blah is between the lower number you get and the upper number you get. What we're finding is we're going to find out essentially the middle 95%. Okay. So in the past, when we've been drawing on a normal curve, we always put the mean in the middle, right? And we're going to do a basic one that's based off 0. And we know we've been saying that 2 tick marks away is 95%. But really, if I'm 95% of the way, I'm not exactly 2 tick marks away. I'm actually 1.96 tick marks away. And we've been using 2 instead just because it's an easier number to find. Okay, and this number, this 1.96, is the amount of tick marks you are away, which is also your critical value, which is down here. We'll talk about it. It's the critical Z. Now, if I were to find this, and it's nice to understand how to find this so that if you don't have the whole number that you can, I need to find out what this place is right here. And so the way you do this, I know that my middle percent here is 95%. So I need to find out what this is. Well, I know that my whole curve is 100%. So if I subtract 95 from that, I get 5%. But I have 2 parts of it that's 5%. And I just want the left part, or I just want the right part. So I take that and I divide by 2, which is 2.5%. So to find the number, you're always going to subtract from 100 and then divide it by 2 because you only want half of the curve, either the lower or the upper. And so now the way this 1.96 comes across, or where you find it, is you do the inverse norm of 0.02501. We're just going to always base it off 0 and 1 because it doesn't really matter what our mean and standard deviation are for these yet. So second distribution. Let's see, there's a reflection on the calculator. There we go. Inverse norm, 0.025 and 0.1. And so that shows me I'm 1.9599. So that's where the 1.96 comes. Now, I know that it's negative, but that's just to the left. I'm just going to disregard the negative. Okay? All right, so the critical Z is the Z score that represents where the center percent falls. It's the beginning or where it ends. Okay? Majority of the time, you're going to have to find a 95% confidence interval, which is 95% in the middle. And so you'll use this 1.96. okay? But sometimes I'm going to have a different number. And so let's say I want to find our 92% confidence interval. And so we have to be able to find our critical value for that. So the normal curve helps me see it. There's my mean. 92% is in here somewhere, right? And so I'm looking for this left side or the right side, one or the other. Well, I know the whole curve's 100%. So 100 minus 92 is 8. So these two highlighted sections make up 8%. So this side is 0.04 and this side is 0.04. So I'm going to do the inverse norm of 0.04 with 0 and 1. And I'm going to keep it with 0 and 1 because, again, I'm just trying to find that z-score, so I don't need real numbers like real means and standard deviations. And so when I need a 92% confidence interval, my critical value is 1.75. And again, we just drop the negative. It doesn't matter if it's negative. I just know that I'm 1.75 tick marks away. So whenever you use a 95%, it's 1.96. Now we found out whenever it's a 92% confidence, it's 1.75. All right, so these are the things that you need to check. We know what a lot of them are. We know what the plausible independence is. That's just saying that there's a good chance or it should be independent. Is it random? Is it less than 10%? And do you have enough successes and failures? And remember, that's the NP is greater than 10 and NQ is greater than or equal to 10. Okay? All right. So now what we're going to do is we are going to talk about this first problem. The first thing we need to do is we need to check our conditions. So in May 2002, a Gallup poll found that 38% of a random sample believe in ghosts. Okay, so people's opinion are independent of each other. So there's the first condition. The second condition is it says it's random. Random sample of 1,012 adults. Third condition is 1,012 less than 10% of the population. So I'm going to combine those two again. It's a random sample of 1,012 adults, which is less than 10% of the population of adults. And then the last one, do we have more than 10 successes and more than 10 failures? So my N is 1,012 times my P, which is 38. So 1,012 times 0.38 is 384. I don't need to really write the decimal because that's way past 10. But then I do the other one times 0.62. And again, that's way above, so that's 627.44. And so since they're both greater than or equal to 10, we can continue. So that's kind of how you have to check your conditions. Some of you have been taking shortcuts and not listing that, but remember you have to list that. All right, so now what I need to do is, since it's asking for 95% confidence, the confidence interval, the way we find it, and somehow I didn't squeeze that in up here. Let's write this down here. Have I written down? The way you find your confidence interval is it's your mean plus or minus, because remember, it's always based off our mean. Can't see the picture. It's always based off our mean. And it's plus or minus our critical value, which we practice finding here. times our standard deviation for our sample, which is our SE. And this, for samples, for proportions, remember, is PQ over N. Okay, so we need to find and interpret our 95% confidence. So I know that my mean is 0.38%. I know that my critical Z is 1.96, and I know that because 95 percentile at the top, we found that. What I'm not sure about is my standard error, so I need to calculate that. So that's going to be 0.38 times 0.62 divided by the number of people in the survey, which is 1,012. So you can plug this in our calculator kind of all at once. So it's the square root of 0.38 times 0.62 divided by 1,012. And so my standard deviation is 0.015. And so what happens is I need to add and subtract that. So my upper, or let's find the lower first. The lower is going to be 0.38 minus 1.96 times my standard error. And then my upper is the same thing, but I'm adding it. So let's see, kind of squeezing it together. So 0.38 minus 1.96 times 0.015. And so my lower is 0.3506. And then my upper, instead of typing it again, I'm just going to go get it and hit plus. And so it's 0.4094. So what this is telling us is that our middle 95% is in between these things. And so when I write my statement, I'm going to go back and reference this up here where it says we're 95% confident that the true proportion of something is between my lower number and my upper number. So what that translates to here is I am 95% confident that the true proportion of adults that believe in ghosts, that's the context, is between 35.1% and 40.9%. So what this confidence interval does is allows us to say this even though we don't know the sample size. Regardless of sample size, I can be 95% confident that the answer I will get will fall in between these two numbers for the percent of people that believe in ghosts. All right, let's go ahead and look at some examples. So the Pew Research surveyed 1,002 American adults and found that 51% feel that Apple should assist the FBI to unlock the San Bernardino attacker's iPhone. Let's focus that on some, maybe a little too far away. There we go. So to determine and interpret a 95% confidence interval, okay, whenever we do this, we have to check our conditions. So our first condition is that it's independent. And so people's opinions will be independent of each other. And we can join in here, or actually no, we can write a sentence later. We also know that it is random because Pew Research probably did a random survey, assume. a random survey, even though it doesn't say it, but we can assume that because it's a pretty reputable survey company. The next thing we have to say is 1,012 less than 10% of the population? Yep. 1,012 people is less than 10% of population. And then the last one we have to do is the success failure. And so that's the NP is greater than or equal to 10. And then Q is greater than or equal to 10. It's not okay just to say that it is. We need to actually do this. So 1,002 times 0.51 and 1,002 times 0.49, because those are the P's and Q's. And so when we multiply those out, I get 511. And then I get 490. So these are both greater than 10 people, so we can move on, okay? But again, you have to first say and explicitly check those conditions. Okay, so the confidence interval is the mean plus or minus the critical times the standard error. All our mean is our P, and for this is 51%, so 0.51. Plus or minus our critical. Well, remember our critical for 90%, we're using 1.96. You'll see that number a lot, so it's helpful to memorize that. And then your standard error, it's the square root of PQ over N. So P is 0.51, Q is 0.49, divided by N, which is 1,002. So I'm going to plug in all this right here. Okay, because I can do that all in one step in my calculator. So 1.96 square root of 0.51 times 0.49 divided by 1,002. And if you notice, I'm still underneath the square root, so this is going to work. So it's going to be 0.51 plus or minus 0.0309. So I'm going to say that's 0.031. So now I'm going to actually do that. I like to start with the minus because I'm always supposed to have the smaller number first. So I'm going to do 0.51 minus 0.031. So I get 0.479. And then I'm going to go up here and change it to plus. So I get 0.541. Okay. And so there's my confidence interval. And then if you notice, it also says to interpret it. So finally, we're going to the last place where we have to say something about it. And make a little box. We are 95% confident that the true proportion, there's another, of Americans that feel Apple should unlock the iPhone is, you can't see all that, between 47.9% and 54.1%. Okay? So I'm 95% confident that the true proportion of Americans that feel Apple should unlock the iPhone is between those percents. That's your confidence interval. Now we need to do the same process for 90%. Now, we've already checked these conditions up here, so I'm not going to check them each time because we know they were met originally, and so we don't need to. And so it's still going to be our mean plus or minus our critical times our margin of error, okay? And I don't know or not my margin of error, but my standard error. The thing is I don't know my critical score, my critical Z. So remember, for a critical Z of 90%, if I draw my normal curve, it's telling me that 90% is in between here, right? So I need to know what's on each side, and that's 0.05. So that's when I do my inverse norm, 0.05, and my base is 0 and 1. And my critical Z is 1.64. So 1.645. So I'm going to say 1.65. And so now I'm going to do the same thing I did above, where I can plug it in. So let's scoot this over so we can see it. There we go. We can see both now. 1.65 square root of 0.51 times 0.49 divided by 1002. And so it's 0.026. So 0.51 plus or minus 0.026. So I'm going to find the lower one first, 0.51 minus that, which is 0.484. And then I'm going to find the bigger one by adding, and I get 0.536. And so it kind of makes sense what we see, because my range is a little bit smaller. And so it's smaller because I have a smaller confidence. If you have a larger confidence interval, you're going to have a larger range. And so it's going to be the same thing. We're 90% confident. And then it's the same thing until we get to our percents. So the more confident you are, the bigger space you're going to have in between. The less confident you are, it's going to be a smaller window. All right, so what we're going to do now is we're going to have to determine some sample size. So for number 3, determine the sample size needed to find a margin of error of 0.01 based on 95% confidence. Well, 95% confidence is right up here, okay? So I know it's going to be 1.96 times the square root of 0.51 times 0.49, but here's the difference. I don't know the n. But I am supposed to get a confidence reading of 0.01. So what I'm going to do is I'm going to start off by just multiplying this top part in the calculator. So let's see if we can get both on here. So let's clear out my screen. So 1.96 times the square root of 0.51 times 0.49. And so now I have 0.01 is equal to 0.9798 over the square root of n. Well, really, I could flip it, or I can know that this goes together. And so it's the square root of n times 0.01 equals that. And now I divide by 0.01. So I divide by 0.01. And now I have another space. The square root of n equals 97.98. Well, the way you get rid of a square root is you square it. And so I square that, and I get 9,600. So the only way that I'm going to get a confidence interval of 1% is I'm going to have to survey 9,600 people, which is a ton. Okay, so same idea down here, except this time, instead of 1.96, I'm going to need to do 1.65. So why don't you pause the video when you think you have it, and then you can check with the answer that I'm about to get. And so it should be 6,803 people. Okay, so hopefully you remember that for each problem you have to go ahead and check your conditions. And then it's the critical Z times the standard of error. And the most common critical Z you're going to have is you're going to have the 95%, which is 1.96.